Hello, friends. Today we'll be looking at problem 101 from LeetCode. It's a symmetric tree. So the problem statement says, given a binary tree, check whether it's a mirror of itself. What that means is whether it's symmetric around its center. Um, this seems like a pretty common problem. It's actually an easy level problem. Once you understand the logic and the pseudocode, it should be pretty easy to code. And it's asked by a bunch of different companies like Amazon, LinkedIn, Bloomberg, Facebook, Google, Microsoft. So most of the top tech companies seem to have asked this in the last 6 months or so. So how do we solve this? Um, it's an easy level problem. I think if we look at some visual cues, it might help understand this problem a little better. So here's a symmetric tree. So what it's asking us is to find if the left and the right side of the tree are mirror images of one another. So what does the left and right side of the tree mean? So essentially what it's saying is if you place a mirror right down the center of the root node, the left and the right should be mirror images of itself. That means everything on this side should be a mirror image of everything on this side. So it should be pretty straightforward. Let's look at how we break this problem down and write it pseudocode. And once we have that, the actual code itself should be pretty straightforward. So what do? We start with the root node, do a null check. If it's not null, we call a helper method and pass its left and its right node to the helper method. Now, what does the helper method do? Now, that's where the big chunk of our actual algorithm is. Let's look at pseudocode for what the helper method would do with these two nodes. It does three things. One, it does a null check. Null check for the left and the right node. It checks to see if the left node is null or the right node is null. And if one of them is null, then it needs to just return whether the other one is null or not. If both are null, it returns true. If one of them is null, then it just returns false. And we already know that the tree is not symmetric. Once we've done that, and we know that both our nodes left and right are not null, the second step is to do a value check. The value check essentially just says, hey, let's look at the value of the left node, compare it with the value of the right node. If they're not the same, return false. As simple as that. Now, if the values are the same, then the third step is to do a simple recursive call and call the helper method again. Now, remember, for the helper method, since we're comparing the entire tree and not just the individual nodes left and right, the helper method now would do two things. One, you call the helper method for the left.left node and compare it with the right.right node. And you call the left.right node and compare it with the right.left node. Now, if both of those calls are true, then it returns true, or if one of them returns false, then it returns false. So that's it. It's a pretty simple helper method. Just does three things: recursively calls all the nodes, and then if one of the calls is false, then we know it's false, or if everything else returns true, then it should be true. So let's quickly look at the code for this. Once you understand the pseudocode, once you've visualized it, I believe it should be pretty straightforward. I just walk through the code. Like I mentioned, if the root is null, then we return true. Now you can return false as long as you tell your interviewer, what the understanding is and you're on the same page. Ask them what the requirement is. You can return true or false depending on what the requirement is. Once you've done the null check, you basically call your helper method like we discussed. Pass the left and the right node of the root. Here's the helper method, three steps. Step one, compare the left and right, see if they're null. Second step is to compare the values. And the third step is the recursive call to left, left, right, right. That's the first one. and then also the left right and right left. So once you're done through this, and if you run your code, it should be pretty straightforward, runs pretty fast, and that's about it. That's all that is to this problem. Now, one more thing I noted was there is a follow-up question where it says, hey, let's see if you can solve it both recursively and iteratively. This was a recursive way to solve it, which is what I would do if I had the option. But we can solve it iteratively as well. I plan to do another video right after this one to add visual cues and a very simple pseudocode on how to do the iterative version of this problem as well. So please do tune in and look at that one as well. Hope you like this video. Please do tune in if you like looking at these visual cues to help write pseudocode and then come up with your code in your own language of choice. Thank you.